In this video, I'm going to create a 3D printed mount to place a standard XT60 power connector on the right side of this ImpulseRC Apex EVO Quadcopter. First, let's take a look at our parts and get a rough idea of how we want to lay them out. Now we'll create a simple hand sketch of the part we wish to create. This will provide us with a starting point, a guide if you will, as we go to make our CAD design. This will also help us make sure we have all the measurements we need before we start to draft the design. Next, we'll take some measurements of the parts and fill these in on our diagram. We'll measure the width of the standoff that we wish to connect the XT60 to, and we'll also take some dimensions of the XT60 connector itself. This is our final drawing. Next, we'll create our design in Fusion 360. We begin the project with an empty design. When first opening Fusion, you should be on a blank design, or you can hit the paper icon in the top left to create a new design. I like to start a design like this with a sketch, so we'll go to Create, New Sketch, and select the bottom plane as we will be drawing a top-down view of our part to start. The first part of the design I like to work with is to get down the general shapes and constraints and refine from there. First, we'll place our standoff. We'll create this on our drawing origin to anchor the design and give us a reference for measurements later on. To draw the standoff, we'll use a hexagon. In Fusion, you can use the 6-sided polygon tool to create one. We know the minimum distance of the standoff, which is also known as the hexagon's minimum diameter, so we'll use the circumscribed polygon tool to draw it. Let's add a few temporary dimensions to constrain this shape. At this point, these are just placeholders, so the specific dimensions are not important. Let's add a dimension to the hexagon to constrain its size. Now we can see that it will still allow us to rotate the hexagon, which is not what we want. The design will assume that the sides of the standoff will be parallel with the sides of the quadcopter, so we'll add a simple vertical constraint to one of the sides, which will now fully constrain this shape, which is seen when all the lines are black. Now we'll add the rectangle to set the position of the XT60. We want to add the rectangle in a particular way. We don't want to use the 2-point or center rectangle, as Fusion 360 will set the rectangleness constraints by using vertical and horizontal constraints, which then constrains us from rotating the XT60, which we will want to be able to do later. So instead, we'll use the 3-point rectangle and intentionally make it not horizontal vertical, which will create constraints that keep the rectangle but still allows us to rotate it. As you can see, the constraints created are keeping the sides parallel with each other and setting one of the corners to perpendicular. This will allow us to resize, reposition, and rotate the rectangle as needed. Now that the shape is made, we'll add dimensions, again temporary, to constrain the shape. As with the standoff, we will adjust these after all of the shapes and constraints are in place. Now we will add the distance constraint between the standoff and the XT60. We'll add this as a distance constraint from the standoff center to the XT60 side. We'll use the standoff center to allow this to rotate and still have a rational distance. Let's also constrain the XT60 in the lengthwise dimension. We will do this by setting the dimension from the standoff center to the back of the XT60. Again, don't worry about the specifics of the dimensions, as we will be making these part of the parametric adjustments we will add shortly, allowing us to adjust the model. Now we are very close. What you will find is we can still rotate the XT60, which is good, as we want to be able to rotate this and adjust the design parametrically later, but we need to add a constraint so we can lock that in and make those adjustments via parameters. The thing is, we need a reference to set the angle to. We can't just slap down an angle with nothing to reference it to. We could make the angle in reference to the side of the standoff, but I find that a little hard to rationalize too, so let's add a reference construction line to work from. We'll draw a line from our center line horizontally across the drawing. Fusion should automatically add a horizontal constraint. If it doesn't, go ahead and add one. Then we'll convert this line to a construction line, and now we can use this line as our angle reference. We added an angle dimension here, and now you'll see as we change that angle, the model rotates as expected, and you'll see all of our lines are now black, indicating we have a fully constrained diagram. We now have a model that we can use to design our actual part. To begin designing the actual parts, we'll need to add some real dimensions, and we are going to do this in a parametric way so that we're able to adjust things as we go. One of the cool things about Fusion 360 is that it lets you add diagram parameters, which you can find under Modify, Change Parameters. These parameters will store the dimensions you added to your diagram so you can easily change them later. You will see here under Model Parameters all the dimensions we have added to the diagram so far. What we want to do is add a list of user parameters, which are named parameters we will use to define our drawing and allow us to make adjustments later. This will be all of the measurements we made earlier and added to the hand drawing. To get started, let's add some user parameters for the standoff, XT60, and top plate. The standoff minimum diameter is 5 millimeters. The width of the XT60 is 8.1 millimeters. The length of the XT60 is 15.5 millimeters. The width of the tip of the XT60 is 3 millimeters. The standoff height is 28 millimeters. The top plate thickness is 2 millimeters. And the height of the XT60 is 15 millimeters. We can also add a parameter for the height of the XT60 above the top plate. I'm going to set this to 4 millimeters, but you can choose whatever value makes sense to you. Since this is a parametric design, it's easy to change this later if we decide we want a different height. Another dimension we'll want is a minimum print thickness. This is the thinnest that any part of the design can be, so it's important to set this correctly. I recommend that the minimum walls are at least double your nozzle diameter. I'm using a 0.5 millimeter nozzle, so I'll set the minimum print thickness to 1 millimeter. If you have a 0.4 millimeter nozzle, which is fairly common, you'll want to set it to 0.8 millimeters. The nice thing about doing this parametrically is that it's really easy to change these values later, so we can adjust our design for different printers or materials. Now we need to go back to the diagram and start entering these parameters for our dimensions. Let's add the standoff, the XT60 width, and the XT60 length. Now there are a few dimensions we haven't measured yet: the angle, the offset, and the distance from the standoff. We can add what we think is reasonable here, or maybe take some quick measurements from the quadcopter. Again, since it's parametric, we can change it later. I often find the easiest way to get these right is to make an educated guess at first, print it out, and adjust what's not right. So we will quickly add parameters for the angle, the distance from the standoff, and the position or offset of the XT60. Then we will plug these into the diagram. Note that it won't let us add the plug angle. It shows as red. This is because we made a mistake on the angle by making it millimeters instead of degrees, so it's not a valid angle. We will need to fix this by deleting that parameter and re-adding it. Fusion will not allow changing the unit of a dimension. Now we can add the angle, and it is fully constrained and parametric. Now we can see what the parameters do for us. We can now go and make changes to these parameters without touching the diagram, and the diagram will adjust. For example, we could change the angle or the distance from the standoff. This can actually be done after all our modeling has been done, and the model will adjust. I'll set these parameters back to where they were, and we'll have a fully constrained and parameterized model. The first step to making the actual part is to draw out the part itself on top of our reference shapes. We will start by finishing the details on the XT60. It's not a rectangle. When I work with parts like this, I presume that the angles are rational. Simple 45 or 90 degree angles usually. Unless I can see they're clearly different, and in this case, they look pretty straightforward, so I assume they're 45 degree angles. So first I just put in these corner lines, actually intentionally not making them 45 degrees and not the same as each other or perpendicular to each other, so that Fusion will not add constraints I don't intend. Then I will go back and add in the angle dimensions. Now the angles are all right, but we can see that it's still a bit out of whack, so we need some more dimensions to lock this all in place. We have the distance between these 2 points, so we will add that constraint as a dimension. It's a dimension we have as the size of the XT60 nose. This still doesn't lock it down because it allows the nose to slide a bit back and forth. So now we need to lock that in at a starting point. This will be the full width of the XT60, less the nose width, which will give us the total amount of space on both sides of the nose. So then we divide that in half to get the space for one side. Now we just trim this down to make the actual XT60 using the trim tool, and then we will see that we have lost some constraints, and some of the lines are now blue. This is because some of the important constraints were on bits we just trimmed off. So first we will restore the length by making a dimension between the front and the back as the XT60 length, and then add the width as well. To draw the part, we will start with the wrap around the standoff. We could do this by using the standoff itself as the inside measurement for this wall, but then we might end up with a part that is too tight. Therefore, we want to add a little bit of margin around the parts we are sliding over. Let's add a parameter for this margin spacing. We will call it margin, and to start with, we will just set it to 0.5 millimeters. This is a great parameter to have adjustable, as we may find that the parts are too tight or too loose and may need to adjust this later. To add the margin, we use the offset tool. We will offset the standoff by the new margin parameter. Then we'll draw the part's actual outside wall, again using the offset tool. Since the tool does not allow us to offset an offset, we will offset the original wall, this time by the minimum wall thickness plus the margin. This will give us a part with a minimum thickness. Now let's do the same thing around the XT60. Offset by the margin, and as you will see, it went the wrong way, so we can force it to go the right way by using a negative offset. Now add the part itself just like we did to the standoff. And now we have a part around the XT60. Something else we may want is a lip at the bottom of the XT60 surround to hold the XT60 in place. So let's draw that with another offset. Let's make it a parameter so we can adjust later if necessary. Create the offset and plug in the parameter we just created. Now we need some structure to support the XT60 from the standoff surround. Let's draw a line in the front. Just to make it easy, let's go point to point. And then let's do the same at the back. Now we don't want this to be some big solid, so let's add some more lines to make these spars. You can see the bottom one here determined we wanted it parallel and added the constraint. But the top did not, so let's go ahead and add that constraint. And now let's set the distance for these spars. And let's do it parametrically, of course, so it can be easily changed later. Now this is starting to look like what we want. So the next thing to do is actually start extruding out the parts. Let's go ahead and click Finish Sketch. We're going to start with the bit that goes around the standoff. So we select that profile, we hit E for extrude, and we set the extrusion to the standoff height. Now we see we have our first bit of part. We're not done yet though. We see that Fusion has hidden our sketch, but we need that still, so we need to turn the sketch back on. Now we will want the XT60 holder, so we select that profile, and we want the spars as well, as we want those to be the same height as the XT60 holder. So we will select those and extrude again, using the XT60 height this time. And now we see something is wrong. The XT60 would be below the top plate, which is not what we wanted if you remember what we had in our drawing. There are a few ways to fix this. For instance, I could have extruded from the top of the standoff, but that wouldn't be right either. So what I would like to do here is set the bottom of the extrusion for the XT60 with an offset. The way we do this is to alter the extrude step and change the start to be an offset instead of the profile plane, and set an offset for how high we want the holder to be. The value we had that relates to this was the rise over the top plate, because we want the connector to stick up above the top plate by that much. So we will add that rise, but that's not really what we want either. So we need to calculate the offset with the values we have. Let's do this with a parameter for easy adjustment later. We'll add a parameter called XT60 bottom, and we will set this value to the standoff height plus the top thickness minus the XT60 height, as we are trying to position the bottom of the XT60. We go ahead and plug in that value. This gets us just about right, except those spars don't look quite right. This is not quite what we want either, so we need to do this as separate steps. So let's do the spars first by leaving out the XT60. We do still want them to start at the same place as the XT60, but should end at the top of the standoff so that they will fit under the top plate. To do this, we just change the extent type from distance to the to object setting and set the top surface of the standoff. And now the spars are exactly how we want them. Now we can put back the XT60 using the values we used the first time. Now you can see this is just a little bit too low, and it's because we forgot the rise over the top, so we need to add this to our offsets. And since we made this parameter, adjusting this is simple. And now you can see this is exactly what we want. Also note that the XT60 bit uses the height for the top, but the spars use the top of the standoff, and they both adjust accordingly. Now one last bit. We need to add the lip to the bottom to hold the XT60 in our mount. So we will select the outline we drew for the lip, but we also need to select that margin because we want the lip to connect to the outer wall. This extrude is going to be offset the same as the wall itself, but we will just use 1 millimeter for the distance, and we end up with a little lip. Now we want to add some final details and make this look like a professional part by smoothing some of the transitions. One of the primary tools we will use for this is the fillet tool, which will round out edge joins. Select the fillet tool, select an edge, and you can drag it out or type in a radius. We will just use 2 millimeters here. Now we will select the rest of the edges with Command-click. And we see a problem here I missed earlier. This fillet is going the wrong way because when we extruded this, we mistakenly made it two separate bodies, so it is actually the edge of a part rather than a join. My mistake, but a chance for me to show how easy this kind of mistake is to fix. Luckily, we don't have to undo and redo all of that work. We can go back to the operation that created the second part and fix it. To find the operation in question, you can select the part in the model, and you can see here on the timeline that the operation is highlighted by 3 vertical bars. Double-click on this operation to open its dialog, and we can see that the operation was set to new body. All we need to do is change that to join, save, and now you'll see we have just one body. Let's turn off the sketch now, as we are done with that, and it will make it easier to see and select edges in our model. Now we go back and use the fillet tool, select our 4 edges, and then we can pull the fillet out or enter the values as we did before. The last thing we want to do is bring down the bottom of these spars and add some vertical support. The way I'm going to do this is use that fillet tool again. Select the edges and pull as before. However, you can see this pull is limited because of where the shapes diverge a bit. We could stop here and it would be okay, but I would like this to come out a bit further, right up to the edge of the XT60 wall. So one way to fix this is to make 2 separate parts for the moment. So we will go back to the action that added the wall, and we will make it a separate part first. As before, click on the part find it in the timeline, double-click to edit, change it from a join to a new body, and save. You will see that this marks the original fillet as a problem because it removed one of the edges, so let's just delete that for now. We'll put it back after we do this. Now let's put this fillet back in. You will see that this allows it to come right up to the edge. And as you see, that's exactly what we were looking for. Except that we again have two bodies. So we need to rejoin those. We can't go back and change the original extrude, as that would remove the references we used to make the chamfer work. So instead, we will rejoin them by using the Combine tool. We select one body as the target, the other as the tool. We don't want to make a new component, and once joined, we can get rid of the original separate piece by not keeping the tool. And now we have one solid piece. Finally, we just need to put those fillets back in on the spars, select all four edges, and pull. And there it is, a part ready to be printed. And here's our first print. As you can see, the first print is a little loose on the standoff and on the XT60. Also, the prop is just clipping the mount, so we need to make some more adjustments. Let's look at the changes we need to make. We need to close up that margin on the standoff and the XT60, as well as bring the XT60 closer to the standoff. Now, here's the cool thing about making this a parametric design. We don't have to start over. We don't have to redraw anything. We just need to change two parameters. We can go to Modify, Change Parameters, and find the margin, and make that smaller. It was quite a bit large, so we will change that to 1/10 of a millimeter. Now we move the whole thing closer to the standoff by changing the distance parameter. Let's make that 9 millimeters. No, that's too much. It was almost right. Let's make it 10 millimeters. Save that, and as you can see, all is still correct, but the gap is much smaller and the mount is closer. Let's print this out. And here's our final print. Let's pull those supports off and see how it fits. Looks pretty good. Let's put it on there. Good fit. Good fit there. Much better fit on the standoff. And look at that clearance for the prop. Top plate's going to look nice. And we've got a great final product. I hope you enjoyed this tutorial and I hope you learned something. If you did, please like, subscribe, hit the notification bell so you can see my next tutorial or my next flying video. Hope to see you again soon.